Let's have a look at this reference design for a power supply with 3 accurately regulated outputs using InnoMux2. InnoMux2 is a flyback IC that's specifically designed for multi-output applications. With its single-stage power architecture, it allows you to eliminate all the downstream DC-to-DC pulse regulators, improve system efficiency, and at the same time maintain accurate regulation on all of the outputs. The system efficiency is over 87% at full load condition from end to end. This is designed for appliances, industrial, or general purpose applications. Now let's have a closer look at the board. This is DER-716. It can deliver 62 watts continuous power and up to 98 watts peak power. The input is from 90 to 265 volt. This power supply is configured for 3 constant voltage outputs, a 5 volt, a 12 volt, and a 24 volt, all independently regulated. The regulation accuracy on each output is within plus or minus 3%, including all tolerances. Because this is an evaluation board, the components are spread out for testing and measurement purposes. However, if it's an actual production board, the size will be substantially reduced. Now let's have a look at the bottom side of the board. This board uses an InnoMux2-EP IC. This is the primary side of the circuit, and this is the secondary side. A 750 volt power GAN switch is in this IC. We achieve zero voltage switching without additional circuitry, and that reduces switching losses. This IC comes in a thermally efficient INSOP 28 package that allows PCB cooling by connecting the source pin to the copper pole. That means no heatsink is needed anymore. So looking at the secondary side, we have 3 outputs, 5 volt, 12 volt, and 24 volt. This is the synchronous rectifier for better efficiency, and this MOSFET is for the 5 volt output. We call it a steering FET or a selection FET, and we use that to steer power only to the output that's requesting it. So for example, in this case, it will be to steer power only to the 5 volt. Similarly, for 12 volt, we have the steering FET for the 12 volt to allow the power to be only steered to 12 volt. So this is the blocking diode for the 24 volt. This blocking diode is used to make sure that 24 volt isn't going to be back charging 12 volt. We also have independent feedbacks over here going into InnoMux2. By doing that, we're able to sense all of the outputs independently and then regulate them with the use of these steering FETs independently. As you can see, there's absolutely no DC-to-DC pulse regulators on the board, but yet we can maintain the accurate regulation on each output. This is all thanks to the single-stage architecture using InnoMux2. To learn more about InnoMux2, please visit power.com.